Right. Yeah, I've not been sleeping very well lately because of well, we've got builders working next door making a racket, and I've also got a lot on my mind with this circuit, this delay line, and I've spent the last few days trying to figure out what my problem is with it, and I've come to the conclusion that my chokes are too small because I fitted sockets in there. There's actually little sockets that you can see that you can plug the capacitors in, and I've been trying different values in there. Now the they work the circuit works best with these smaller value capacitors. Now this is 22 microfarad, and I had four 10 microfarads in all the slots before, and it was working quite well. So I took them out, and I put these sockets in so I could swap the capacitors more easily. And I've been trying different capacitors, and obviously what the problem is the chokes themselves. It's because the frequency, resonant frequency of the chokes is well, it's too high for this particular frequency of what the device is running at, which is around 50 hertz. It varies, obviously, but depends on the speed. But it's probably running at about 30 hertz at the moment. So I've been thinking about this, and I need bigger toroids. That's what I need. I mean, this is a bigger toroid at this end. It's inside the 3D printed plastic. I don't know if I can grab one. Hang on a minute. I've got one over here. I've been winding this one actually, but it's similar to that. I've been winding one of these yellow ones, and I kind of got distracted from doing that. But yeah, I'm probably going to go back and continue winding. But I think I'm gonna change the wire maybe. But it's the amount of inductance. You see, when you're stuck when you're stuck to a situation where a small value capacitor works better than a larger value capacitor, that tells you that the actual choke itself can only take a small pulse, and it can't really withstand a bigger pulse or a larger amount of energy because of the size of the inductor. It's just not gonna. It needs basically frequency, higher frequency, and it doesn't have that. So I'm not going to go and start getting massive toroids. You know, we're talking about 6 inches wide. That's ridiculous. That's just overkill. I don't need that. I just need a series of toroids in a line to give me the same effect, and I can keep the size down that way. And but I need to use the bigger ones, I think, because each toroid will store energy, and it creates a delay and then another delay on the next one and so on, which is what I'm trying to achieve, is get the delay and store that energy in the inductor, which is basically bounce back out of phase back at the generator coil to offset the drag, which is what I'm trying to work out. And well, it will work if I get the flipping inductor right. And so anyway, then I'll be able to use slightly bigger capacitors as well, because the capacitor itself, there's a direct correlation between the capacitor and the inductor. I lost my circuit again. Right, okay, I found it. Right, if you look at the diagram, right, the the amount of energy that's stored in the capacitor is proportional to the inductor, because the inductor creates a delay. So when an initial charge of energy comes into the inductor, it actually has a high impedance for a brief amount of time, which we're talking about microseconds. So it has a high impedance, which means it's not actually, it doesn't charge the capacitor up immediately. There's a slight delay, a fraction of a delay, as the inductor saturates, and then the power is charged to the capacitor. So what you have, because a capacitor is the opposite of an inductor. A capacitor has an initial low impedance when you first start to charge it, whereas the inductor has a high impedance when you start to charge it. So they work together. So if the capacitor itself is small and it doesn't work with a larger capacitor, that means that the inductors too wants to be bigger. We need more millihenries basically. So that's the way it works. I don't know what this stuff is on the paper. Sorry about the mess. I think I dropped some gravy on it. Oh, anyway, yeah. Anyway, I can tell it's not working properly because my triac isn't actually getting warm, so there's not much power getting through to the circuit. Anyway, yeah, just need scratching my head. But anyway, we're about 60 milliamps output right now. Into about 8 volts. So I can look at my scope and see that we're at cyclic 9.2 volts, but there's a voltage drop of about a volt or so across the whole system. So into the charge capacity, it'll be about 8 point something volts. Let's check it anyway. I'll turn the meter off on there to save energy, because let's just push the button, get it to come on a minute and have a look where it is. Yeah, it's about 8.8 volts, right? Which is what I said it would be. About 8 volts anyway, I thought. So anyway, it's running at the moment right now. We're consuming 290, well, 300 milliamps. We're at 13.8 volts. So anyway, it seems to be self-stabilizing. It's even more stable right now because the RPM isn't changing much between. We're at about 3,100 RPM. Now, when I started charging the supercapacitors up, which are right up there at the back, when I started charging them up, I was at about 3-4 volts or something. My current initially when I was tuning this went up to about 80 milliamps on the output stage, and I was fiddling about with it for quite a long time. When I got it set a certain way, I think the voltage was about 5 volts, 5.5, 6 volts on the supercapacitor output. Then I noticed that my RPM was about 2,900 RPM. That's 2,000, nearly 3,000 RPM. And my current was about 16 milliamps output. And it stayed at that, right between that voltage and where we are now at 8 volts, which is really weird. It's kind of interesting that, because it seems to be self-governing. That means I'm getting a constant current output, and I'm also getting a constant RPM, and also a constant input current, which is very interesting, because that's not, it didn't happen quite like that before. I did get some of that. It did behave a little bit like that, but not as much, as profound as it is now. But it seems to be self-regulating in that the RPM isn't really changing a lot, but my current output is constant, which is really interesting. So just by changing those capacitors, it's changed quite a few things. It's yeah, I'm pretty sure it's because I've also got I'm still using the trigger coils on the actual generating coil, so that's probably interfering with it a little bit as well. That's probably where the self-regulation's coming from. I printed some more bobbins. There were bobbin holders. They're on the print bed. I need to get them installed. I've got 2 in here anyway. I'm just lazy. I've been sorting this Delayline circuit out, and I need to get extra coils in there, parallel them up and see where we are, and yeah. So that's another thing to do. So I need to get that sorted. I'm probably going to get that sorted out next week sometime, probably Monday, Tuesday or something. Because I'm actually thinking about designing a new circuit board for the Delayline, but I've got to get that other board that's still on the breadboard over there with all the coils still attached. All the coils are still attached on there, all the these sense trigger coils. They're all still attached on this board. I need to get all this lot stuck on a circuit board, then I can clear my breadboard and start working on it. I think I'll probably build a delay line circuit on the breadboard, and then I can play around with it a lot more, because putting it straight onto a circuit board has given me a few headaches because of the capacitor changes and desoldering, and yeah, it's just a bit it's a mess. It's getting a mess. So the board's starting to warp because of all the soldering I've been doing on the board. Yeah. What else is there? Not much. Nothing else I can report. Except that the delay line, I do feel that that is the key to getting this thing working. I just haven't got enough of it yet, enough delay on it. When I adjust the trimmer pot, I can adjust the timing by moving the coils, which are down there. That's the trigger for the triac. These coils, and it's also the exit coil. So I can move the coils physically, and I can also adjust the trimmer pot. Now, if I turn the trimmer pot a little bit too far to the right, what happens? What happens is, I'll just explain it because it's difficult to show all this all at the same time. The little pulses that you can see there, what happens is I adjust the trimmer pot as this little pulse here and the one down at the bottom there. As I adjust it, this pulse moves to the left of this waveform, and as it moves over to the left, the RPM slows down, and as it slows down, my current output goes up, but it only goes up temporarily, because as it slows down, the current basically falls back down to the same level it was at before. If I move this little peak on the trimmer to the edge of this waveform, right about here, it just suddenly disappears. It just flies off. It seems to lose sync. These little peaks just seem to disappear when I get right on the edge of the waveform. At that moment, the whole thing just slows down. The RPM just drops like a stone. I lose about 100 RPM. So I'm trying to keep this little peak here right on the edge without it falling off the edge, because once it drops off the edge, that's when the RPM goes crazy. I don't know if I can show you this. I'm gonna have to stand over here and try and show you this, what I mean. Right, that's the current right now. It's about 59. Right, I'm gonna stick my screwdriver in this trimmer pot, and I'll show you what I mean, and you'll get an idea. Now, you might be able to hear the thing running in the background. Now, watch what happens to the RPM and that little peak. So the RPM's in the red thing, this thing here. Right. Okay, right, watch the peak. I'll try and keep the camera still. Now look at the RPM. It's dropping. It's gone off the edge. Bring it back. There. The peak. Move it to the left. Oh, it's a bit twitchy actually. It's a bit hard to get it just right. Get it about there. Right on the edge. Then the RPM just shoots up. And my current has dropped a bit, but the RPM's gaining, and as it gains, the current output starts going up as well. Right, what are we at the moment? It's still on the edge there. I think I've got it too near the edge actually. Sorry about moving the camera around. Some people get dizzy. Right, I'm just going to tweak it back a bit. It's easy to adjust it with a coil, moving that, but right, I think it's about there where I had it. Anyway, the RPM stabilising now. So it's a bit touchy on the trimmer. Current is 59, 60 milliamps. We're back to about where we were before. So just to give you a rough idea about this, about how the delay line does work, but it's a bit touchy, and it should be a bit better if I can get a better choke arrangement. I also noticed that if the RPM gets up to too high, I'll lose those peaks just drop off the edge. It's like they fall off a cliff basically and disappear, and then my current, it slows down and current goes up. Current on the output goes up. RPM drops. But it's not so bad really, because when the RPM's going up anyway at a certain threshold point, the actual current demand has dropped anyway, so I don't lose all that much RPM as it gets faster and faster. But yeah, anyway, that's all for now. You've got a rough idea of what I'm faced with. It's a daunting task trying to sort this circuit out. Anyway, I think that's it for now. Current wise, we're stable. Anyway, good night.